Okay, so today we're going to finish up section 8. Today we're going to be solving rational inequalities. So they're going to be fractions. So again, just like yesterday with the quadratic inequalities, we need to get our inequality to have a 0 on one side of our inequality symbol. Then what we're going to do is find a common denominator. So we're going to combine terms so that there's just one fraction on either the left or the right side. Then after we do that, we are going to set the numerator equal to 0 and the denominator equal to 0. Then we will graph just like we did yesterday by using test points in between our different little sections that we create on our number line. Do not try to solve this as if it's a proportion. We cannot solve it that way. We actually have to simplify it to one fraction and then set the numerator equal to 0 and the denominator. So let's go ahead and try the first example. Again, I need to get that 1 to the left side so my inequality has a 0 in it. So I'm going to subtract 1 from both sides. And now I have 5 over x plus 4 minus 1 greater than or equal to 0. Now I need to find a common denominator. My common denominator is going to be x plus 4. Now I'm not trying to eliminate the denominator, I'm just trying to make it into a single fraction that I can combine. Now, when I did it with my first period class, I did it all in one step. They wanted to see it separately. So really what I'm doing here is multiplying top and bottom by x plus 4 to get the common denominator. So the first fraction was good. I can also do a keep flip change here, make this a -1, and that's what I'm going to distribute. So -1 to the x, -1 to the 4. Now that I have a common denominator, I need to combine my like terms in the numerator. So I'm going to do 5 minus 4, and I get 1 minus x over x plus 4. Now I have a single fraction. Now I'm going to take the numerator, set it equal to 0, and take the denominator, set it equal to 0. Once I solve for x on each of these are going to give me my cutoff points on my number line. So for the first one, I could just move the x, get 1 equals x. I could flip it around. Move the 4, and I get x equals -4. I'm now going to add these numbers to my number line, least to greatest. And now I pick a test point. I'm going to go ahead and choose 0. 0 is located here in the middle. So I'm going to plug in 0 to the original inequality. So 5 over 0 plus 4 greater than or equal to 1. 0 plus 4 is just 4. So 5 over 4, is that greater than or equal to 1? Yes, it is. 5 over 4 is like 1 1/4 or 1.25. So this is true. So my section with the 0 gets the check mark, and then the two sections on the outsides get the x's. So now what I need to do is write interval notation for this and graph it. Now here's the tricky part. Remember, when we were solving the rational equations, remember whenever we got an answer, we had to check it to make sure it didn't make the denominator 0? Notice this answer that I just got, -4, when I plug that into my denominator, it makes my denominator 0. So all I'm going to do is change the bracket that should have been around that number to a parentheses. So bottom line here, just to simplify everything, whenever your symbol in the original problem is a less than or equal to or a greater than or equal to, the only number that gets a bracket is the solution from the numerator. Okay? Any other time, every single number gets a parentheses. The denominator numbers will always get a parentheses. Yes?
Could you repeat what you said that whenever the symbol in the original problem is?
So whenever the symbol in the original problem starts out with either a less than or equal to or a greater than or equal to, the only number in your interval notation that gets a bracket is the solution from the numerator. Denominator, no matter what symbol you have, will always have parentheses. That just simplified everything, okay? Because technically you're thinking, okay, this symbol started with a less than or equal to or a greater than or equal to, so I should have brackets in my answer. But the problem here is the answer we got from the denominator would make my problem undefined. So I want to include it in my answer, but not the number itself, but right when we jump off of it. So like when I go to graph this, so let's go ahead and look at it now. So when I go to graph this, where the -4 is, don't put a bracket, it'll be a parentheses, because if I were to say -3.75, that would be a good answer. I don't want to put my bracket on a -3, like the next integer down. So that's why I just do a parentheses, because what that means is it starts at -4, but it doesn't include it. When it's the bracket, it means it includes it and everything that's either less than or greater than. So now for the 1 though, it gets the bracket and then you join it. So in interval notation, it'll be a parenthesis around -4, but a bracket around +1. So just remember, any solution or any breaking point that you get from the denominator will always have a parenthesis around it. Just like the infinity and the negative infinity always gets a parenthesis. However, the numerator, if your problem has a greater than or equal to or a less than or equal to, that numerator number gets a bracket. Let's try the next one. Now again, remember on WebAssign, if you were to enter this as 1, -4, it will mark it wrong. Okay? If you write your answer on the test, those of you who are in here in the classroom, if you tell me the answer is this, it's wrong. It has to be least to greatest. Let's try the next one. There's nothing to move. It already has the 0. There's no common denominator to find. It's already simplified. So now I just take my numerator, set it equal to 0. Take my denominator, set it equal to 0. Now this one's just a greater than. So all of our symbols here are going to be parentheses. We don't have to worry about which one's a bracket. But again, when it's that other symbol, it's always just the numerator. So let's solve this one. -1, add 4. So now I'm going to add these two numbers to my number line, least to greatest. I'm going to choose my test point. Again, I'm going to pick 0 because it wasn't one of my answers. So now I'm going to plug it into the original. So 0 plus 1, 0 minus 4, 0 plus 1 is 1, 0 minus 4 is -4. -1/4 is not greater than 0. This is a false statement. So the section that has the 0, which is right in the middle, gets the X, and then the two ends get the check marks. So my graph here is going to be parentheses going to negative infinity, parentheses going to infinity. Interval notation, negative infinity up to -1, unioned with 4 to infinity. So for number 3, we do have something we need to move. We need to move the 4. Again, do not try to put a 1 under the 4 and solve it as a proportion. You will get it wrong. So here we need to move it over. So now we have 2x minus 1 over 3x plus 4 minus 4. Now I need to find a common denominator. So what this second fraction needs is the 3x plus 4. So the first one, I'm just going to write it continuous. You could do it separately like I did the other example, but I'm just going to put the -4 and then the 3x plus 4 and then put the same denominator under it. I'm going to distribute the -4. So the 2x minus 1 is good. Negative 12x minus 16. I need to add my like terms in the numerator. So 2 minus 12 is -10. And -1 minus 16 is -17. I now take my numerator, set it equal to 0. Take my denominator, set it equal to 0. So -10x minus 17 equals 0. 3x plus 4 equals 0. I'm going to solve by adding 17. -10x equals 17. Divide by -10. X is equal to 17 over -10. Now, for our purposes, we can leave it like that. But remember, when you're doing WebAssign, they're going to have a bunch of numbers. So you're going to need to know where to put this. So this is actually, if I make it a decimal, it's going to be -1.7. Or if you make it a mixed number, -1 7/10. And then over here, subtract the 4, divide by 3, x equals -4/3. Again, for WebAssign, we would make this -1 1/3, or a -1.3 repeating. Because we need to know where to place the parenthesis here. So now let's add these numbers to my number line. Now, the 1 7/10 is the smaller number, because 7/10, technically, if it were positive, is the bigger number. So this is going to be the -17 over 10, or if you put it like that, either way. So now my 0 is located on the far right, because both of my answers here were negative. So over here is the 0. So let me plug it in to the original. So 2 times 0 minus 1, 3 times 0 plus 4, and I'm going to see if that's less than 4. So I get -1/4. This is a true statement. So I'm going to put my check mark over here where the 0 is, and then repeat the pattern. So this started out as a less than, so they're all parentheses. So this one will be a parenthesis going that way, parenthesis going that way. Interval notation, -infinity, comma, -17 over 10, unioned with -4/3 to infinity. My next one is over here. Again, I need to move the 2 because I need a 0 there. So subtract 2. 6 over 5 minus 3x minus 2. Common denominator again. My common denominator is going to be the 5 minus 3x. So 6. And then what I can do is this needs the 5 minus 3x. 5 minus 3x. So negative 2 times 5 minus 3x. And then I can just write the denominator once. I need to distribute the red. So 6, negative 10, plus 6x over 5 minus 3x. I'm going to add my like terms in my numerator. 6 minus 10 is negative 4. So here I can get 6x minus 4 over 5 minus 3x. I now have it simplified down into one fraction. So now what I can do is set the numerator equal to 0 and the denominator. Let's see, I got room here. Okay, so 6x minus 4 equals 0, and 5 minus 3x equals 0. I'm going to add 4. 6x equals 4. Divide by 6. X equals 4 over 6, which simplifies to 2/3. Then over here, I can add the 3x. 5 equals 3x. Divide by 3. And x equals 5 over 3. So if I were doing this on WebAssign, 5 over 3 is 1 2/3. So just so I know that I need to put it between 1 and 2 when I go to graph it. But for my purposes here, I'm just going to put it on my number line least to greatest. So the 2/3 goes here, and the 5/3 goes here. Again, these are both positive, so my 0 is located over here to the far left. So let me go ahead and take my original problem and plug in 0. So 6 over 5 times 3 times 0, less than or equal to 2. 6/5 less than or equal to 2. This is 1 1/5. So this is a true statement. So where I have the 0 gets a check mark, then an X, then a check. So graphically, this one is just, okay, so here again, remember the denominator answer, which is this one, gets a parenthesis. The only thing that gets the bracket is the 2/3. So here, this will be a bracket going this way, but this will be a parenthesis going this way. So negative infinity up to 2/3 with a bracket, unioned with 5/3, parentheses, infinity.
Why does that one give parentheses and that one give a bracket?
Okay, so whenever it's this symbol, so less than or equal to, or greater than or equal to, the only one that gets a bracket is the numerator answer.
Okay.
Everything else is always a parentheses. Again, the reason why we change the denominator to a parentheses is because if I were to plug in 5/3 to my denominator, it would make it equal 0. So I don't want to include 5/3 in my answer. That's why it's a parentheses. It's like an open circle. It's just the starting point. 5. They get a little bit more complicated because now we've got a common denominator that's actually going to be x times 3x plus 2. It's going to be both of these. So again, I need to move this over first. If you wanted to move the other one over the other way, you could have, but I'm just going to go ahead and move it over. That's what I've been doing consistently here. So negative 5 over 3x plus 2 minus 5 over x greater than or equal to 0. So again, my common denominator is both. So the first fraction is missing the x. The second fraction is missing the 3x plus 2. So what I need to do is multiply that numerator. The denominator, do not distribute. Leave it factored. So I'm going to leave my denominator as x times 3x plus 2. Because if you distribute it, you're just going to have to go back and factor it once you set it equal to 0. So never distribute the denominator. But we do have to distribute and combine like terms in the numerator. So the first fraction is just negative 5x. The second fraction, when I distribute this negative 5, this becomes negative 15x minus 10. I now need to combine the like terms in the numerator. So I can combine the negative 5 and the negative 15. And I get negative 20x minus 10. Again, leave the denominator alone. And this is greater than or equal to 0. Now that I have a single fraction, I set the numerator equal to 0 and the denominator. Again, the only thing that's going to get a bracket is that numerator number. So 20x, negative 20x, minus 10 equals 0. Add 10. Negative 20x equals 10. Divide by negative 20. And x equals negative 1/2. For my denominator, I'm setting this equal to 0. Notice it's already factored, so I just take each factor and set them equal to 0. So first that one, and then this one. I need to solve the second one. The first one already gave me my answer. So 3x equals negative 2, divide by 3, and my answer here is negative 2/3. Now remember, these two answers, because they came from the denominator, are going to have parentheses. This is the only answer that's going to get brackets around it. So let's go ahead and add 3 numbers to my number line. This is what happened in number 8 yesterday in the 1.8a notes. So if you didn't get a chance to watch how it came up with 3 answers, this is what number 8 did. It gave 4 sections now that we would be putting in numbers. So I'm going to again put it least to greatest. So my smallest is the negative 1/2. Then, actually no, the negative 2/3. Negative 2/3, then the negative 1/2, and then the 0. Now, for this one, I cannot choose 0 as a test point because that was one of my answers. Yes? Okay, so I actually have to pick a number from one of the areas. I could either choose something that's less than negative 2/3, in between negative 2/3 and negative 1/2, and chances of me wanting to pick a fraction to plug in, forget it. So I'm going to pick 1. That's going to be probably one of the easier numbers for me to test out. Maybe even negative 1 wouldn't be bad. But I'm going to plug in positive 1 to my original equation to see if that section gets the check or the x. So negative 5 over 3 times 1 plus 2 greater than or equal to 5 over 1. Negative 5, 3 times 1 is 3, plus 2 is 5. I can simplify 5 divided by 1 is just 5. And then this gives me negative 1 greater than or equal to 5. Well, negative 1 is not greater than or equal to 5. This is false. So the area where the positive 1 was located gets the x, and then check x, check x. The pattern repeats. So again, remember the only number that was going to get a bracket is the half. So right here, this is the bracket. Everything else are parentheses. So my answer in interval notation would be from negative infinity to negative 2/3 union bracket 0 parentheses. All right, number 6. Still a little bit more complicated, but really not that bad. Again, my common denominator is going to be both of these, but I need to move it over first. So I'm going to subtract the 3 over 2x plus 1. So now I have 1 over x minus 3 minus 3 over 2x plus 1 less than or equal to 0. Now if you want to go ahead and do a keep flip change here and just make this a negative 3, so that way we remember what we're distributing. So again, my common denominator is both. So it's going to be the x minus 3 and the 2x plus 1. So this fraction is missing the 2x plus 1. This fraction is missing the x minus 3. Again, for the denominator, do not FOIL it, but the numerator we must. So over here, the first fraction just stays 2x plus 1, because 1 times anything is itself. And then the second fraction, I'm distributing the negative 3. So this becomes negative 3x plus 9. I now need to combine my like terms in my numerator. So 2x minus 3x is negative x, and then 1 plus 9 is 10. I now have it simplified to a single fraction. I set my numerator equal to 0 and my denominator. So for my numerator, negative x plus 10 equals 0. Add the x. You could subtract the 10, but then you have to divide. So it's a lot easier just to move the x. So x equals 10. Remember the numerator, because the original symbol was a less than or equal to, this is the only thing that'll have a bracket around it once we're done. Then the denominator, you take each of the factors, because we didn't FOIL here, because if we FOILed, we'd have to go back and break it down again. Set each equal to 0. Divide by 2, and x equals negative 1/2. So I actually have 3 numbers again to put onto my number line. So my number line is here, least to greatest. So the negative 1/2 first, then the positive 3, then the positive 10. Again, choose a test point. I could choose 11, but really I don't want to have to do a bunch of math. I'm going to go ahead and plug in 0. So my original problem was 1 over 0 minus 3 less than or equal to 3 over 2 times 0 plus 1. This gives me 1 over negative 3. This gives me 3 over 1. Negative 1/3 is less than or equal to 3. This is true. So the section that had the 0 is getting the check mark. Repeat the pattern. And now we'll write our interval notation and also graph it. So for the graph, again, remember the only thing that got the bracket was this 10. These are both parentheses because they came from the denominator. So in interval notation, this would be from -1/2 to +3, union bracket 10 to infinity. So again, I need to get a 0 there, so I'm going to move the 3 over. 2x minus 7 over x minus 5 minus, and I could put 3 over 1. Common denominator here is going to be x minus 5. So this is the only fraction that needs me to add to it. So now it's going to be 2x minus 7. Distribute the -3. Keep the x minus 5 in the bottom. Combine my like terms in the numerator. 2x minus 3x is -1x. And then -7 plus 15 is +8. I now have a single fraction. I set my numerator equal to 0 and my denominator. So for my numerator, I'm just going to add the x. X equals 8. And for the denominator, I'll add 5. And x equals +5. Let me go ahead and add this to my number line. Least to greatest, so 5 first, then the 8. My 0 is located way over here on the left side, so I can go ahead and plug in the 0. So 2 times 0 minus 7, 0 minus 5, less than or equal to 3. -7 over -5. Negative divided by a negative is a positive. But this still is just 1 2/5, which is less than 3. So this is true. So this section gets, where the 0 is, gets a check. Then x, then check. So now, again, this had a less than or equal to. So remember, only the numerator gets the bracket. So from the 8 up, it's a bracket, but this side is a parentheses. So from -infinity up to the +5, unioned with the bracket around the 8 to infinity. So again, when you're doing the WebAssign homework, just be careful. If you're using the equation editor, you can use the infinity symbol. If you're not, you're typing the word infinity on questions like this. If you have the wrong grouping symbol, it will mark it wrong. So just be careful.